All right. Heather, did you already do introductions?
I did not. Go ahead.
Okay. Hi, everybody. I'm Janine Shepard, and this is Heather Brown. And we are ISBE Math Content Specialists through the Center for Educational Initiatives at Illinois State University. And we're really excited today to share Math Talks with you, one of our favorite strategies. And of course, our charge is to support all of the teachers in the state of Illinois with the implementation of the Illinois Learning Standards. So anytime that you need our support, we are just an email away.
And the reason we do IO MathCom every week is, who knows the answer? Go ahead, Jeannie.
The joy, wonder, and beauty of mathematics.
There you go. Along with NCTM, we're big into trying to spread the joy, wonder, and beauty of mathematics. Okay.
And that's one of the reasons that we love Math Talks, is it really addresses some of the cultural shifts that we're trying to achieve in mathematics. So it's just a great 5 to 10 minute activity that you can do at any time during your math class. And they're fairly easy to implement, and they're fun, and they just really address some of these shifts that we're trying to achieve. So in order to facilitate a math talk, there's 6 steps. The first is the teacher is going to pose a purposeful problem, and we'll dig a little deeper into what kinds of problems we select for these activities a little bit later on. After the teacher has presented the problem to the students are going to signal when they are ready to share a solution. And we usually signal with a thumbs up against our chest. And if students have additional time, if there's still time to think, then they can tell us other strategies to arrive at the same answer by giving us additional fingers in keeping them engaged in the problem. The teacher then collects the answers orally, and students explain or defend their answers. The teacher records these students' strategies and asks questions to facilitate mathematical discourse. And then finally, the class comes to a consensus. So we are going to now experience a few math talks, and then we'll dig a little bit deeper into some of these particulars and considerations.
No, it's fine. So why don't you go ahead and actually show the numbers? So it is going to just be, oh, it's okay. I'll show it. It is 38 plus 37 is the first one we're going to do. And what I'm going to do is I'm going to ask you all to follow along with me on this. And when you have an answer, the reason we wanted you to show your cameras is because I need you to put a thumbs up when you have an answer. And if you already have an answer and you have more than one way to do it, I want you to start putting up another finger and see if you can go all the way to 5, but otherwise you can stay wherever you are at the point. So I want you to actually do this with me, and we are going to start one. And I'm going to try to watch your screens at the same time that we start kind of looking at the problem. So the problem was, no, I just lost it, 38 plus 37. All right, now that I see most people have a thumb up, some people have multiple fingers, I want to know, first of all, what your answer was. So I'm just going to ask everyone to kind of give me your answer. Lauren, what did you have for an answer?
75.
Great. Hillary?
75.
Great. Melissa? Melissa, did you unmute?
75.
Okay, if you got 75, can you give me a little like surfs up shake? Okay, so right now we're gonna go ahead with the assumption that 75 is our answer, and we're gonna go from there. So now I'm thinking about strategies. What is the strategy that you use to do this? If you would like to volunteer, you can raise your hand.
Right.
Melissa, you're not on mute, so I'm gonna go ahead and ask you to give us give us the strategy of how you did it.
I did it old school. 8 and 7 is 15. Carry the 1. 3 and 3 is 6. 1 is 7.
All right, I'm going to stop you there. Sorry, you did the one method that I'm going to ask you to explain. 8 plus 7 is 15. And then what did you do?
Then I just took the 1 from the 10s. 3 and 3 is 6 and 1 is 7.
Where's the 3 and where's the 3?
10's place.
Okay, so it's actually
30 and 30.
All right, 30
I
and
said
30.
It was old school. I have to work hard to do it this new way.
And you did the 30 and 30 and the 10. And then, nope, that's 70. Look at me. I'm going to fix this. So it's something like this, and then she added those and got something like that. All right, I usually hope that that's not the first response I get, because I do kind of pick on that person a little bit more, because I think what Melissa was telling us that she
way, because I would never do it that way.
I think what Melissa was actually telling us that she did is she did this. Is that correct?
Yes.
And you got 15, and 15 makes a 10 and a 5?
A 10 and a 5.
And so then we had the 3, which is the 30 plus the 30 plus the 1 gave us 75. Okay. Who can give me a different way to do it?
I'm just going to put myself on mute now so you won't talk.
Gail?
If you take the 2 from the 37 and put it with the 38, you get 40.
Okay. I'm sorry. I totally just went ahead of you. I'm breaking all my rules.
And
you
40 plus 35 is 75.
75. Did anybody use that method? Great. Who can give me another method? Lauren, go ahead.
So I made the 37 a 40, and then I made the 38 a 40, and then I subtracted 5.
So tell me how you made it a 40.
So I added 3 to 37, and then I added 2 to the 38, and then subtracted the 5. Mm-hmm.
Is that close to what you did?
Yeah. Mm-hmm.
All right. Anyone else? Who has another method? Go ahead, Hillary.
I used doubles facts, so I did 37 doubled plus 1 more. So 37 plus 37 is 74, and 1 more is 75.
And where did you knew that fact, 37 plus 37?
No, I used the place value strategy, and I decomposed 37 into 30 and 7. So I doubled 30, and then I doubled 7, and I combined my 10s, and then I added my 1s.
Okay. So you kind of did multiple steps there. Got it.
Yes.
All right. Any other methods? All right. So we think we got 75 was our final answer, and we have all of these different strategies. Great. Do you want me to throw it back to you, Janine?
Yes, perfect. Can I share my screen?
Do you want, okay, sorry. Yes, you should be able to. We're using new technology today too. Hi, extra people that joined.
All right, so why this strategy is so effective? Is my screen shared correctly?
Mm-hmm.
Okay.
Yes.
Is students become more active listeners because they're eager to hear the different strategies that are being shared. A lot of classrooms, this becomes kind of competitive. Like how many different strategies can we explore today? Like how many can we share? How many can we get up on the board? So they're trying to like beat their record from previous math talks. The emphasis is on the solution path or the strategy, not on the answer. So that's a cultural shift that we're really trying to, hold on, I need to mute somebody. It's a cultural shift that we're trying to achieve in the classroom. Where I can't find who I need to mute. I'm so sorry.
I think it's, Deb, the three of you that are in the same room, it's creating an echo. Deb and Rob and Melissa. If you guys can just mute. Perfect. Thank you.
All right. So the idea that mathematics, historically, we've been very focused on getting the correct answer. And really, there's a lot more learning and deeper conceptual understanding if we focus on the strategy or the pathway to the answer instead. So that's one of the great things about Math Talks is we are really focused on the strategies, and we can not worry as much about the solution. And then we achieve a deeper conceptual understanding because we're analyzing the mathematical reasoning behind all of these different strategies. So we could go on with all the strategies that you guys just shared from 37 plus 38 and dig really deep into why that traditional algorithm that Melissa shared, how that relates to the decomposing strategy that Lauren shared. And we can really compare and contrast and talk about, okay, which of these strategies is the most efficient? Is it always the most efficient strategy? And give us an example of when it is and when it isn't, and really see the connections there. And students are using the skills that they are most comfortable with. So Heather and I like to share this strategy as an inclusive differentiation strategy. So it's instead of us deciding who our low-level students are and our high-level students are, all of the students are engaging in the same grade level appropriate task, but approaching it with the skills that they have mastered. And then because we're digging deeper into these other strategies and they're getting to see how other students solved it, then we're pushing them beyond their comfort zone and hopefully helping them achieve these the deeper conceptual understanding so they can apply those strategies in the future. So some things to consider when you are getting ready to facilitate a math talk is, what is the intent of the problem that you're sharing? So are you wanting to review a skill that is imperative to an upcoming unit or lesson? So something from the previous grade level, or something from a previous unit earlier in your school year? Or are you wanting to introduce a new type of problem that maybe they haven't seen before, and you're wanting to see how they'll use the skills that they've learned earlier in the year and apply them in this new situation? So there can be a lot of different purposes for the problem that you're engaging them in. We also suggest using PARC released items for math talks. It's a great way to get students used to the language of the PARC problems. For a multiple choice, we like to strip away the multiple choice options and just give them the math problem for the math talk. It's important to anticipate how your students will respond to the problem. So what strategies are you going to see, and how will you write those problems on the board? How will you record their strategies for the students? It's also important, as you're anticipating student responses, how are you going to draw the connections that you want the students to identify? How are you going to, my third point, summarize the mathematical residue? So making connections between the shared strategies to develop that deeper conceptual understanding, and then also discuss those efficiencies across cases.
Good. And before we move on from there, Janine, I just want to think of, like, anticipating student responses is a great one that we actually talk about a lot. We talk about it with lesson study. We talk about it in general. It's just really thinking about how students are going to respond to something. And Janine and I did a session last February, and we realized we hadn't done our due diligence. And as soon as people started giving us answers to a problem, which is the one we're going to do next, all of a sudden I was like, oh my gosh, I didn't think about how they were going to do that. And so I had to think about what it meant and what they were saying, and so therefore how I would write it. And that's kind of an important thing to think about. So I think that's the next slide, right? Is going to that problem. So if you want to stop sharing, I will share again. And we will try this again. Perfect. So if instead we go to this problem, and again, I can't see you all that well, so if you can hold your thumb kind of high up, that would be perfect. When you have an answer for this, I want you to give me a thumbs up. And if you have more than one method for getting an answer, I want you to give me an extra finger in the process. And ideally, we're doing these in our heads. I'm just going to throw that out there. So I think there is a time and a place for these to be with paper. But if you can keep it up high, that would be awesome, because I'm looking at a little tiny picture of you. And if you have more than one method, give me another finger. Don't pick selectively which finger you give me. All right, okay, give me some solutions. I want to hear some solutions from what you had. So the people I have on my screen, Gail, what did you get as a solution?
I got 600.
600? Lauren? Actually, go ahead. You're muted.
That's okay. I think I read it the other way because I got 200.
200?
Yes.
Okay. All right, Hillary?
Also 600. But I too had to read it twice because when I read it the first time, I read it incorrectly. So I went back and I reread it, and then I realized what I think to be the true question.
Okay, so 600 and 200. Anyone else? Rod, Melissa, Julie? Did anybody get a different answer? Rod? Oh, I can't hear you. You might have to go on someone else's. It says you unmuted, but there's no sound. Melissa, are you in the same room?
Yeah, 375.
475. Okay.
No, 375.
I'm sorry, 375. Okay.
Shouldn't you want to sit in front of mine? Because I gotta go. I have a conference.
Oh, no.
All right. So then let's think about processes. So right now, these are the answers that are kind of on the table. So let's talk through what are some of the processes that we had. So someone explain to me what you did to get the answer. You want to raise your hand? Gail, you have a big smile. Go ahead.
So I started almost guess and check and said if the computer was originally $400, 75% off means I'd pay $100. And then I used ratio thinking and said, well, if I paid $150, it had to be $600 then.
Okay. So did you set up a ratio?
But
Did you like set up a proportion?
in my head, yes, I just scaled up kind of.
Okay. So if 400 goes to 100, then to get 150, it would have to be 600?
Yes.
Okay. If you used a method similar to what Gail did, can you give me a I agree symbol? All right, Melissa, you had your hand up. So I want to make sure I give you the opportunity. Go ahead, tell us what you did.
I don't even know how to work this thing.
I unmuted you.
Oh,
You're
okay.
good.
So actually, when I was trying to do it in my head, it was really confusing because I don't work like that. So I was doing more like 150 equals 0.75 times X, divide 150 by 0.75 so you could get with the discount. It's $600 is the original price.
So what
I
happened
could
when
never do it in my head.
But did you do 150 divided by 0.75?
Yeah, and then I realized that wasn't the right way to do it, so I divided it by 0.25 instead because you're actually paying 25% if you're getting 75% off.
Oh, I see. So 0.7, this didn't give you 0.75. This gave you 375?
I'm trying to get my screen back because all I can see is me. Oh.
And instead, you realize that that wasn't right. It should have been 150 equals 0.25.
25, right.
And then
Because
if we
that's
did
what you're
it,
paying, right. And then,
so I'm going to put a red X through this because you realize that wasn't right.
right.
Is that correct? So then do you
Yep.
think 375 is no longer an answer?
Yes, that is no longer an answer.
Okay. All right. So she gave us one method and you used it. You did go to a calculator for that. Is that what you said?
I did go to a calculator because I can't, yeah.
Okay. All right. Give me another method.
That would have went 150 with that.
I'm listening to you, Rod, or I was listening to you through hers. But now you're muted again. Hold on.
Unmute myself.
Okay, there you go. You just talk loudly, Rod.
I'm good at that. I went with 150 was at 50% of 100. If 150 was 50%, I made it 300. And then what's the extra 25% was 75 more. So that's where I got 375. So I broke the 75% into two pieces, two easy numbers, 50% and 25%. That's how I did it. And I added it to the 150.
And it became 375?
Yeah.
All right. Explain this to me again. So 150 is 50% of 300.
Yep. And then 25% of 100 is $75. So when you add it all together, that equal to 375.
But why are you
No,
using?
you said the way he was thinking was, okay, so if 150 is half of 300,
Yep.
and then I need 25% more. So what he did was half of 50% is 25%, and half of 150 is 75. That's where he got the 75.
Okay, but then
And then I don't know how somehow he added the 75 to the 300.
What's the original 300? 50, 100.
does it make sense to you? Rod, do you still agree with that answer?
Yeah, do I know it's right? No, I know it's wrong, but that's how I did it, yes.
Okay.
I know it's
So
wrong, though.
you think it's wrong. And the reason you think it's wrong is why?
Because the other two people got 600, and their justifications made more sense.
Ah, okay. All right. That's reason enough to listen to other people, right? Who had another method?
I used a bar model.
Perfect. Thank you. Who said that? Hillary?
Hillary, yes.
Okay.
So if I knew after rereading it the second time that $150 represented 25% of the original price, so I drew a bar model with 4 units because 25% is 1/4. And then if 1 unit was 150, 4 units was 600 just by simple multiplication.
Like that?
Yeah, I mean, yes. That's, yes. In my head, I did 150 is 300, and then I doubled 300.
Okay. Or 150 plus 150 is 300 times 2 is 600. Okay. Another method. Lauren, go ahead.
Yep. So originally I had done mine, if you scroll up a little bit, Heather, where it was the blue writing there. And when I did that, I actually got that 200. So I had misread the problem that you're actually paying for 25% of it. So when I was checking my work, I'm like, okay, that doesn't really make sense. When I was looking through, I just did a little like ratio diagram, like a little chart where I just did a T chart with the percent amount and then the actual amount.
Okay.
And then I just put in original, change, and then the new amount. And then I just started plugging in some information to make sure I was setting up my equation right. And that's where I was like, no, I should have done it the other way with 25% to get.
Can you tell us like what some of those numbers were?
Yeah. So in the percent original, I just put 100%. And then the percent change, I put minus 75. So the new amount you're paying is really 25% of that original, just to understand the problem a little bit better. And then for actual, I don't know the original actual amount, so I just put a variable in. And then in the new amount, I put 150 and just solved for the change. So it just helped me make that equation a little bit.
Okay. And then you came up with what is your answer?
Then I got the 600.
600.
Mm-hmm. Because I added the 150 plus the 450.
Oh, that this had to be 450.
Yeah. Mm-hmm. So I solved for that. And then I could add the 450 and 150 just to check my work.
Okay. I see what you're saying. Good. Any other methods? I don't know if Rod's convinced you guys. Julie, how'd you do it?
No, Rod's question was, he teaches fourth grade, so he's like, this can't be a fourth grade question because it's the percent's too high. And I said, I bet it's a fourth grade question.
It is a sixth grade question. It's
okay.
3.
Yeah, he said the percent is too high to be a fourth grade question. So that's why he was shaking his head. Sorry.
That's okay. This is a 6RP3 is what we have it tagged as. So if we look at the different solutions, so when we came up with this, so Lauren, you're saying your answer was 200 and now you want to get rid of that. Is that correct?
Yes, I had originally done it the way with the blue, the 150 divided by 0.75. I actually got 200 for that.
It probably was 200. I just was trying to figure out where 375 came from. Okay, so we have different ways of doing this. So what are the advantage of us doing these different methods? Just listening to your conversation, what are some of the advantages? We might question the wording. Maybe as a teacher, truthfully, some of the feedback I might get from this is that I need to make sure my wording is a little more clear. If this is something that could be interpreted a different way, I can think about that. Number talks kind of give you some real live feedback of not just seeing a student's answer, but understanding how they interpreted it. What else did doing it this way do?
I think for me, it helps see other ways of actually doing the problem. Even if the answer isn't correct, I can still see, okay, so this is another way. Like, for example, the bar model that one participant mentioned, I was thinking, wow, that's really efficient. That's an easy way of solving it. So it helped me see that connection.
Yes? What else? Melissa, you had your hand up?
I was going to say something along the lines of what Lauren said. I always, just because of my math experience and taking calculus and stuff, I just naturally always go to the algebraic way of solving things. And so I never even think, it's really hard for me to think of another way to do it. And then but then when I see the ways, when I saw the bar method, I was like, oh, well, that was really quick and easy. Mm-hmm. And then the T-chart even, I was like, oh, that makes sense, because then you can see 25 times 4 is 100. So if your new price is 150, multiply it by 4 and you get 600, and you can easily figure it out that way. But I would never come up with those on my own.
Yeah. What else? So I think I'm going to stop here just so I can see everybody at the same time. I think this is part of the reason that we do it, is exactly what you guys were just saying and sometimes I think when we do 37 plus 38, which is the one we kind of default to the most often, is we don't really see that transition, because most of us can solve 37 plus 38 relatively quickly. And we can kind of, if you asked us to solve it by adding ones first or by approximating first and then figuring how much we moved it by, we can kind of justify those. But when you get into percents, I think it's a good one for us to use, because chances are somebody on the line hasn't seen a method. And we also have, I can show you the double number line method on this. It's a good way if a teacher wants to introduce a method, you can certainly at the end introduce the method. By the time we were all done talking, you may have had another method in your I don't know, what do I want to say, in your trick bag that you could try a different time that you were given a problem. You also, we kind of settled on an answer. So we kind of, by the end, kind of took to figuring out what the answer was. We kind of figured out how some misconceptions could occur and kind of found a way to get rid of those misconceptions in the process. Now, I'm not sure 100% everybody was convinced at the end, but overall, I think more of us were satisfied with where we were and kind of understood a little more about what was going on. So I will show the double number line real quick, if it lets me share again. Which was another one that I heard that I wasn't prepared for, is they did, how many of you are familiar with a double number line? So we know when this percent is 0, so is the, well, I'm just going to do a dollar sign. So is the cost. And we know that when the percent is, no, I just lost the problem. We want to know when it is, and somebody might immediately jump to when the percent is 25, it's 150. Then we have a couple options. We can either scale this up and say what happens at 50, 75, and 100. Or in one of the sessions I did, they actually scaled down to what happens at 1%. And they found that at 1%, this number would be 6. How many of you are familiar with a double number line? Raise your hand if you are not familiar with a double number line. Okay, you're shaking your head no. I can see that. Okay, so a double number line, probably the place we're most common with a double number line is actually a ruler. And if we think of it like a ruler, that probably helps you out a lot more, is a ruler at this mark right here, I can say that's 12 inches, but that's also 1 foot, right? We could also even do, it's also 1/3 of a yard, or if we wanted to, we could even say like what percent of a decimal it is. But the double number line idea is that I can, as long as we start at 0 with both of these, and this one is inches and this one is feet. I just want you guys to know that my handwriting is equally as bad in person as it is on an iPad, but I'm going to blame it on the stylus. I can scroll up. I can go further. The number line is infinite, right? So I can go to any number I want, but I can see at 24 inches, that's 2 feet. Or I could go to a smaller number and say at 6 inches, that's a 1/2 feet. And the idea being that I'm using my double number line as a scale. And that's why if you actually, I know my dad's a mechanic, he has the three-sided the ruler that they refer to it as a scale because of that very reason. That's what they use it for. So, but the double number line is definitely a way to do this as well. So this is a number talk gives you a good chance to include these. All right, I'm going to go ahead and do one more with you. And one of these we actually usually do in kind of a flash way. So I'm going to go ahead and I'm going to show you this. And I want you to tell me how many points are in this screen, are in this image. And I'm going to turn this off in just a second. So I just stopped it, and I want you to tell me how many points were in that image, and if you can tell me how you figured that out. How many of you are upset that you didn't look at the image right?
Do you want our answers? Sorry.
No. There's people are still thinking. I see people counting in their heads like this. Mainly Rod. Yeah. All right, give me how many points do you think there were?
I think there was 21.
All right, Jenny says 21, right, Jenny?
Yes.
If you think it's 21, can you give me a shake? All right, if you got a different number, let me know. All right, let's go back and look at it then. Again, with the iPad, it has a 3, 2, 1 countdown to get back to the screen. All right, and we said 21. Ideally, when I'm doing this, I'm not giving you enough time to actually count the points. That's not the goal. My goal is instead to get us talking about this. So how did you get 21? Jenny, you gave it to us first and we haven't heard much from you. Can you explain to me how you saw the 21?
I noticed that the top 2 rows were the same as the bottom 2 rows, so I just doubled that and then counted the middle.
You noticed the double 2 rows were the same as?
The top and the bottom were the same, and then counted the middle row.
Okay.
The top 2 rows had 9 in them, so the bottom 2 rows had 9 in them because they were like mirror images, and then counted the middle row of 3.
Okay, so you said this was 9, and this was 9, and then that was 3. Okay? Who saw it a different way? Julie, go ahead.
I looked at it as a 5 by 5 square, and so if every point was there, it would have been 5 times 5 or 25. And since you indicated that you weren't going to give us a lot of time, I just counted the number of dots that are missing and noticed that 4 were missing.
Oh, that was not the right pen. Okay, so you had 25 minus 4.
Mm-hmm.
All right, that didn't really explain what you did. But you know what I meant. There's 4 missing. All right, give me another method. Katie, was that your method?
It was close.
Okay.
I noticed that there were 5 on each side as well. And then I kind of mentally counted the corners, I guess. I did go around it at first and then wanted to be more efficient when you said we weren't having much time. So I counted the 4 corners and realized that since there's 5 on a side, there's 3 in between, and added those, and then added the 5 in the middle. Can you still see me and hear me? Sorry, my internet.
Yeah, something like that.
Okay.
Is that right?
Yeah.
So this was 5, 3, 5, 3, and 5. Yeah. Anybody do it a different method? Rod, do we get your method in there? Because you were doing lots of pointing. You're muted again. We still can't hear you. Well, Melissa, can you unmute? There you go.
Yeah.
I did the same way she did, except I went 5 on top, 5 in the middle, 5 on the bottom, and 3s on the sides. The 5s just stick out in my brain. I can see it easily. I went 5, 5, 5. So I skipped counted by 5s, and then I added in the others, this 2 other side. Yep.
All right, great. So what's the reason then, we could look at this. This is a common question that's asked. We could look at this multiple ways. There's different ones. This is actually, I'll show you this one, is a common one that's asked by Joe Bowler a lot. She uses this. Why would I use, what's the advantage of doing a dot plot if I'm in math class?
There's access for everybody. There's no math skill needed. Not no math skill, but no higher level math skill, so everyone can participate equally.
Yeah. Yeah, and that's really the goal. The goal is, a lot of times with number talks, what we find is when students are comfortable, the students that maybe don't come across initially as being our best and math students end up actually doing great at number talks because they like giving creative ways to do it or a different way to do this. And sometimes to get students out of the box to see that they're one of those creative thinkers it's a really good thing to do when you're starting number talks, is actually to start with a dot talk. Because when students see them, they're not, students that do have some sort of anxiety about mathematics don't have time to realize that's what they're doing. So it's kind of the encouragements that we want to talk about. Janine, do you want to take this back and show IL Teach and Talk? How many of you are already doing number talks in your class, or if you're a coach, you're helping people do them? All right, a little bit, great. Do you guys have anything else? Janine's going to share a website that we have and a couple more slides for us to kind of think about.
May I jump in for a moment?
Yeah, of course.
Another good thing about starting with the dots I have found is that kids, at least in my school, aren't really comfortable with or know how to talk to each other mathematically. And so this is a really easy way for them to start to learn those skills. Not looking to the teacher to direct the conversation, but then conversing with each other and giving each other feedback and being respectful in their disagreement and adding on. And so it's a good way to teach that mathematical practice and give them, experience with something that isn't threatening, but they can practice that skill of conversing.
Absolutely. And I think that's kind of what we saw probably more with the ratio one than the other ones, is this ability. I started hearing people say, well, what I even just hearing like Melissa help explain for Rod what he did. Like she was able to say, here's the part I understood, and then he did this, which I didn't understand. And that's a really good language to have students start working, right? To start using, is we want them to have those. And the same is true, like when you see the dots, like Rod was able to say, I did it the same way as Katie, except I did it on these sides instead of, I counted top and the bottom as 5s instead of the 2 sides as 5. And it's good for students to see that those little things, we want them to be able to say, I did it almost the same way, so that they recognize that there is flexibility in what you do, but you may be basically doing the same thing. And then you can start, that's how you can kind of start to show connections between, we didn't spend enough time probably doing that, is showing connections between different solutions. Is really showing how a student who did 30 plus 30 equaled 60 is the same as a student who's adding down when Melissa added using the standard algorithm. All right, Janine, do you want to show IL Teach and Talk and go through the last few slides?
Sure, yeah. So this is our IL Teach and Talk page. And you can see it's www.ilteachandtalk.org. So on this, we have, it's just a really great resource for math talks and for understanding the standards in general. So you can see they're sorted by grade level and by standard. So I'm going to go to 7th grade RP2. And when I click on that, it is going to give me a teacher guide and a daily discourse PowerPoint. So when I click on the teacher guide, the wind is making the internet very slow, apparently. Here we go. It gives me the standard, and then it also gives me a whole bunch of background information. So there's just a deeper understanding of the standard itself, some explanations and examples, going to give, this one's a long one. It gives us coherence and connections. So it shows you how this standard connects to 6th grade standards and the 8th grade standards. So you know where your students are coming from and what you're preparing them for next. It gives you the evidence statements from our PARC evidence statements. Some classroom resources and higher order thinking questions. And then some additional resources that you can explore to find problems or to find a deeper understanding for you or your students. Heather, do you have anything to add on that, on the teacher guide?
No, I think that's great.
When you click on the daily discourse PowerPoint, open, here we go. All right, the first slide is always the standard and some background information for the teacher. But then each slide beyond that is a math talk slide. So you're not supposed to do all the slides in one class period or anything. It's one slide per math talk. So if you're doing a math talk that day, then you can just pick one of these slides and facilitate it with your students. And these are editable. So if you wanted to make the numbers in the math talk more compatible or less compatible to change the rigor of the problem for your class, you can, or to change the context to make it more relevant for your students, you can do that. You can see each problem is a little bit different. Any questions about the website? All right, I'm going to go back to our PowerPoint. Okay, so what we love about Math Talks, I already kind of talked about how we're really capturing or embracing some of the cultural shifts that we want to see in our math classrooms. So that idea of focusing on the strategies instead of the solutions, and focusing on that flexibility that we want our students to embrace, and making those deeper connections and getting to see how all of these strategies are related, and looking for that deeper structure. But also there's connections here to a lot of other aspects of our teaching. So teacher evaluation, this definitely has strong connections to the Danielson framework. This engages students in discourse, which is a big part of the social emotional learning goal number 2, where your students have to learn to communicate with each other in a collegial manner. So we're engaging them in that. This addresses fluency. So by developing a deeper conceptual understanding, we're becoming more fluent. This is part of growth mindset. We need to learn how to fail publicly, right? And learn from our mistakes, and not be afraid to make these mistakes, that we can actually learn more from making a mistake than getting it correct the first time. This is a great tool for formative assessment. We're getting a whole bunch of data from our students by facilitating a math talk. We're seeing, by seeing which strategies they're selecting, it tells us a lot about where they are in their development of their math skills. And then we're making sure that we're engaging all of our students at the rigor that we want to see them for this grade level. So we're engaging all levels of learners in the same rigorous grade level appropriate math problem. So some concerns about math talks that we hear a lot when we present is sometimes we hear that their students are probably they're not going to get the participation that they want to see. Like they'll have a few students that participate, and then others that sit back and wait for the mathy students to do the work for them. So how many of you think that could be an issue in your math class?
And part of that we didn't talk about, Janine, is the idea of how we're using signals and how that helps get students to participate.
Right.
Is that the reason we do the thumbs up and the number counting is multiple reasons, but one is that we don't have that kid like flapping his hands straight up and down going, I know, distracting the other students, which was me, I admit. But it is a matter of having the students put a thumb up, they hold it to their chest so that they're saying, I'm holding my answer close, I'm letting the teacher know I have an answer, but I'm not necessarily distracting other students. And then it also gives the students, because you're willing to, you can give more wait time, because you're willing to wait till some students get up to 4 or 5 solution strategies to do it. And so some of your kids are going to want to come up with multiple solution strategies. So when we start increasing our wait time, we found it's I've actually seen more classrooms where they have a hard time limiting it to 5 minutes than we do classrooms where it does not take very long for students to all feel like they want to be heard, especially when they start seeing that you allow different answers. And again, I think starting with those dot talks is really a way to kind of get those conversations started so that students get used to those ideas.
The dot talks were really revolutionary for me, or changed my mindset when I saw how, like, in a group of adults, I would get 12 or more different ways that people counted that dot pattern. Like, if our brains are processing that data in that many different ways, then how are they processing the numbers differently too? I mean, that's huge. So embracing that and then capitalizing on it to benefit our math instruction is life-changing.
Mm-hmm.
I don't understand what the student is saying. So that is a great fear. When you're up there and you're recording student responses and you don't understand the strategy that the student is sharing with you, what do you do? What are some options to overcome that challenge? I think we actually observed a great example here. So with Rod and Melissa. So Heather wasn't necessarily understanding exactly what Rod was sharing. And then Melissa stepped in and was able to say, I think this is what he did. And that's a great example. So you can actually call on the student next door and say, can you tell me what they're sharing? Because a lot of times the students will understand each other a little bit better sometimes than the teacher understands the student.
And Hillary, it looked like you had an answer there. Was it similar or something? Do you want to add something else?
Well, what I use is what I tend to say, even before number talks, just in general, when I don't understand what students are saying, I'm honest, and I just say, my brain's not understanding you. Can you say it in a different way? Can you use different words? I want to know what you're saying. And they find a way, and then we figure it out.
And I think it's part of like the teacher stepping back from always being the authority too, right? Is when the student owns that answer. It's not an answer the teacher can make up. So when you ask, you're saying, I value what you're saying. I need you to explain it to me so that I understand it, because you're the only person who really understands your thinking.
And I love to, Heather's really good at this. I'm not as good. But she's not celebrating the solutions that are shared. She's kind of keeping the level head and the same tone and the same response, because all of the solution strategies have an equal value. It's not one strategy is so much better than the other strategy. So that encourages all of our students to share and encourages them to really help us understand what they're saying. So, and I think we've already kind of addressed that only a few students participate. How to handle mistakes. So what about when a wrong answer is shared?
And I think we showed that, right? Like if a wrong answer is shared, we just kept it up there until they or someone else corrected it. And I think that's the best way to do it. I mean, I'm really glad that we had that example, that we left the 200 and the 375 up there until someone that said, I was that answer, and I don't think that answer is right anymore. And here's how I know that.
Well, and I think there's so much value too into looking at how did we arrive at the wrong answer. So there was some conceptual understanding, mm-hmm. like probably some correct conceptual understanding that was engaged to start that path. And then where did we go wrong? Where did we get off track? And so that is a great way to prevent those mistakes from happening later on in a high stakes environment, such as a quiz or a test or a state assessment.
Right.
And then how do I keep the conversation going?
And that's kind of the same thing again. I think the how to handle mistakes is the other thing. I think it's good for students to see teachers occasionally make mistakes. Absolutely. So I don't think there's anything wrong with saying like, oop, I made a mistake, and use either an eraser, or if you are a person who wants to do a single cross out so that you're showing that the mistake happened, it still exists, but then moving on, I think it's useful to do that.
And being graceful as we do so. I think that's important, that we model how to make mistakes gracefully.
Mm-hmm. All right, then we just have a few resources here that you can look at. These are a couple different, the first two are books. U Cubed is Joe Bowler's work. She has a ton of stuff on Math Talks and Number Talks. And we're just about out of time. So does anybody else have any questions about how to use them or suggestions for what you have that you use? I can copy these into the forum so that if people want to come back later and look at the forum, they can certainly find those there. Does anybody have any questions? You can either unmute or you can type them in. Either of those is fine.
I just had a quick question too. When I work with a lot of different teams, I often get the question, like, how many number talks per week or per unit should we embed? And we'll start looking at the problems to say, okay, this one really meets our need. Let's put this one in here. But there's a lot of variability that comes with that. Do you have any suggestions on how many the teachers should do per week?
There are a lot of teachers who are married to it and will do 5 a week. We'll do 1 every day. I do think it's a good warm up to enter math and use it as, like Janine said at the beginning, to either transition from something you've done before or transition into something new. I don't think that it has to be an everyday thing. I think it's useful to do 1 or 2 times a week so that it becomes a practice that they're familiar with. Hillary, it seems like you coach people a lot on using them. How often do the teachers work with them?
So I have some teachers doing it once a week, twice a week, 3 times a week. And it's in my very limited experience, 3 times a week is the sweet spot. Once or twice a week is just too disconnected. And I agree with you, Heather, 5 times seems a little bit too much. And that either the Monday, Wednesday, Friday, or the Tuesday, Wednesday, Thursday really allows for continuity and excitement to build and it to become part of their expectations for the week, and they look forward to it.
Mm-hmm. Great. Any other questions?
May I suggest there's a great YouTube video of Sherry Parrish doing a professional development number talks workshop.
Yeah.
I don't know, should I type it in once I find the YouTube address?
Yeah, you can either type it in the chat window in the next minute or two. Otherwise, if you can go onto our forum, absolutely just go ahead and add it. On our regular on the Math Teachers in Action page, and it'll be there forever. And those forums get a lot of hits. You see a lot of people viewing them. All right, so then the last thing that I need you to do is we really, really, really need you to fill out our post survey and give us suggestions for future sessions to do, as well as for us to collect data so that, like we said at the beginning, we can continue to offer these. Thanks so much for coming. It's 4:30 and we try to limit these to an hour. So thank you all. If you have further questions, feel free to email Janine or I, or if you have questions for other participants, we can try to hook you up.